Welcome to Mr. Diego Tutoring on Instagram, Crushing Chemistry on YouTube. This is the third part of our three-part series on a paper 2 style question. And this is a very tricky one. So watch until the end if you want to learn how to defend yourself from all the distractors that are out there trying to get you. I know it might be a little long, but watch until the end. Let's read the question, shall we? Lithium reacts with water to form an alkaline solution. A 0.200 gram piece of lithium was placed in 500 milliliters or centimeters cube of water. Calculate the volume of hydrogen gas produced in centimeters cube. This is going to be crucial right here.
Huge distractor.
If the temperature was 22.5 Celsius and the pressure was 103 kilopascal, PV equals nRT. We're solving for V, so V is going to be equal to our number of moles, our R, temperature in Kelvin, and pressure in kilopascal. There are 4 things we need to figure out. 1, what number of moles do we use and why? And how do we know? 2, what is up with R? What's with all these units? And why do I need to multiply by 10 to the third or 1,000 in the end? That's very important. And 3, temperature, how to convert Celsius to Kelvin. Pressure, we're just going to use the number that was given to us. So let's start. 1, what number of moles are we going to use? Where does this number 0.0144 for moles come from? We know from B that we have 0.0288 moles of lithium.
Go back.
If you didn't watch it. And we also know the coefficients. All you have to do is set up a dimensional analysis here. I don't want moles of lithium, put it in the denominator. I want moles of hydrogen, and just repeat the coefficient. The coefficient for hydrogen is 1. The coefficient for moles of lithium is 2.
Go back to the previous question.
R. What's up with R? This is a tricky one. If you go to your data booklet, you'll see that R will be equal to 8.31 joules per Kelvin mole. Now, this can be expressed in 2 ways. Either kilopascal per liter, not what the question asked. It wants in milliliter or centimeters cubed. Or, worse yet, in this case, it could be in pascal by meter cubed, which is 1,000 liters. So this is way worse. We're not going to use this one. Now, our pressure is in the correct unit already, but our result is going to come out in liters. So what do? We multiply by 1,000 because 1 liter is equal to 1,000 milliliters. What's going on with temperature? Our temperature is 22.5 Celsius. We have to convert it to Kelvin. So we just add 22.5 plus 273 and we get the number 295.5 Kelvin. And the pressure is already in the right units. So we're solving for V. P goes to the other side. Look how beautifully the units cross out. Mole with mole, Kelvin with Kelvin, kilopascal with kilopascals. But the problem is the leftover unit is liters. The question wants the results in milliliters. So what are we going to do? We're going to multiply everyone by 1,000 in the end. Now that you know everything, let's plug the numbers, shall we? N is equal to 0.0144 mole. R is 8.31 kilopascals per liter over mole Kelvin times 295.5. Everything divided by 103 kilopascals. Look at how beautifully the units cross out. If you plug this correctly in your calculator, 0.0144 times 8.31 times 295.5 times 10 to the 3 divided by 103, you'll have the wonderful result of 343 point something, but we're going to ignore that because 343 already makes up for 3 significant figures, and this is our final result. And don't forget, follow me on social media, subscribe to my channels, and DM me for individual sessions. If you want to start your semester right, if you want to start 11th grade, if you want to start 12th grade right, DM me, have some private tutoring. It's good for you. See you next time. Have a good weekend, everyone. See you later.